So, everyone, in the next 10 minutes, we'll go over a theory of everything. People have been trying to figure out humanity's biggest quest is trying to understand why we exist, what the hell is going on. And at this, me and my lead author of this paper, my co-founder Chetan Singh Chauhan, we have a paper at our hand called as Recursive Becoming Theory. And I know it might seem for a lot of people that you can't really understand theory of everything unless you're a physicist or a strong mathematician or a science. But over here, over the next 10 minutes, I'll like to set context and then you can work with this PDF. The paper itself, I'll give you the resources and the GitHub that we have, as well as then you'll need some LLM smart agent to work through and understand it even deeper. And the beauty of recursive becoming theory, and even before that, let's start with why do we even need a theory of everything once again? And yeah, so we'll start from here. So over the last many centuries, humanity has gone through from Newton to Maxwell to general relativity to quantum. And even today, when we try to put everything together from general relativity to standard model to lambda CDM, there are still 26 plus or close to 2 dozen empirically tuned constants that we have to fit in. And we have to treat some aspects of physics separately. And we are still unable to answer simple, or we still have open mysteries like dark matter, dark energy. So it was very profound for me growing up to realize that humans still have a lot to figure out. It's beautiful in that fashion as well. And so recursive becoming follows a different route. We will start with nothing. We will start with nothing, a basic zero and a delta glitch that we can call as a bit flip. That's it. And from there itself, with very simple axioms that you're not. And what we have been able to find out through this is that what follows through from here and from mathematics, a single self-counting process. So because we are starting from here, there is no difference between law and stuff. So and, observed is usually always contained in observe, and the bookkeeping of this ledger is going to give us probability theory, Gauss symmetry, general relativity, particle spectrum, thermodynamics, chemistry, and cognition. So basically everything, and that's why we are claiming for a toe for recursive becoming theory. All right, let's start. Even more, we have two foundational axioms that we start with. One is zero, and the other is that nothing can come from outside in the system. As this starts, we see that at time itself, at every n equal to 1, 0, 2, 3, 4, 5, there is an update function on our universe. And from there, we see that the Born rule, which is basically quantum physics, is going to be derived. And we derive the whole of mathematics itself from the countings, natural number to real number to rational number to complex number, and then we introduce two extra tag axes, quaternions that help us extend into our complex plane into a couple of more axes. With three axes, we get the SU2, which is spin, and charge we already get in the complex plane, and then we get to SU3, which helps us derive the whole standard model. We also derive a couple of new particles, and we'll go through that. And the flow of the paper will be that we'll formulate the two axioms, then we'll prove the recursion uniqueness from the quarter turn rule. Then we'll derive mathematics, basic algebra. Then we'll go to the probability. We'll understand quantum physics. From there, we'll understand where do we have standing waves in this prediction. Then we go and understand each voxel in this 3D lattice. Then between those voxels, we see tensor, which is basically space curvature. From there, we are able to determine Einstein's equations as well as the gravity's tensor. We use it to fit back in our Gauss stack, and that helps us get to the mass spectrum. Then we extend this further to the large scales of cosmology, chemistry, superconductors, and yeah, we also predict dark matter called as neutral knot. You can call it noton, and it's a lot of places. It's basically space that has folded in itself. It's topologically stable, unlike other particles, and so it leaves a 3.54 kilo electron volt X-ray light. It's just that it's a curvature photon. It's unlike other photons, so humanity hasn't been able to properly detect it because we consider the energy to only be in 0 to 2 grades sometimes, or 0 to 4 grades, and consider the remaining as background noise. But RBT predicts what the shape is, and they're happy to inform that we have also been able to not just predict it, but also go through the existing data of past space scans. And from Xrism, it's all shared on GitHub. I'll show in the Ignite ledger as well. And yeah, so we have been able to detect a lot of anchor summaries for RBT. So, we have actually four anchors, and these are all claiming above 5 sigma. So, I will request your 10 more minutes after the introduction to quickly run you through, give you an overview. And yeah, with Xrism, then again with Chandra, and then we see in different data sets our predictions, coming as we were hoping them to come. All right, so we'll just continue on our paper. So with our foundational axioms well established, we reach to immediate consequence. So there's nothing that we are assuming in the background, unlike other theories. And from here, we'll go on. So time is basically counting. That's where it starts off with. It's the most fundamental physical seconds. Nothing else can measure them. There are no free constants. Whatever it is, it's going to be derived. It's counting identities within because of our limits. We'll see the limit. Probability is basically if two branches, so at every moment of time, the universe keeps branching into two quarter turn splits, plus pi by 2, minus pi by 2, something like that. And that relative appearance of different branches is what is probability. And from here on, we'll see a stable E naught, which is a quantum of energy, and an M star. So everything that will come out will be a rational multiple of these M star. We predict how rest masses of particles emerge themselves. From this, we see that the entropy is also one. The energy required to commit 1 bit per Planck time is what is unitary entropy, and it's irreversible. We see that the total weight of all possible universes is one, and the rule has to be described in itself. From this, we get that there's only one equation that satisfies the emergence of the complex plane is the quarter turn phase that we are talking about. And when it reaches two axis is when SU2 come to be, so these are those three orthogonal planes to these axes over here. And then we see at octonions giving us 7 axes, and on there we see 7 stable, and then the point itself. So 8 different particles over there. So we'll come back. And yeah, so we see from the glitch, we get to numbers, then we get to the whole algebra, then we get to what I was talking about from here. And yeah, then we'll get to space time and then come back. And as I was telling, so we'll derive the numbers, and the numbers then go to the extra axis as I was talking about. Then we see, the phenoplane orientation coming with the octonion stability. And SU3 is where we get our colors. We obviously see a lot of coarse grain, but fundamental. Each Imagining the universe as a 3D lattice, each voxel has a research as well. So as I was telling you guys, there's a weight that's stored. Then there's a phase letter, you can call it Z. That is one iota, minus one, minus iota, and that holds the charge. And normalize seven component vector on the unit, seven spare octononial imaginary. And this gets it the spin as well as the charge. SU2 and SU3 got interaction. So, this is what's happening there. Let's move forward. Let's move forward. Then we see uh, deriving basically quantum physics. As we see that the quantum turn update rule is the only one that satisfies. So after that, the relative ratio of appearance is basically Born rule. And, we are able to expand upon it. I can also, maybe here also I can help you understand. So if we just look at it, so each Planck tick doubles the branch list, magnitude halves, phase jumps plus pi by 2 minus pi by 2. And yeah, the absolute is identical, only the phase records in each weight is the branch count into one fixed modulus. And interference works. Two branches that reunite at a later stage carry the phases. The sum can cancel or amplify because the magnitudes are equal. Hence, all quantum interference patterns survive. The probability formula simply counts how many phase paths land on each detector pixel. So, within RBT, all the quantum interference patterns are able to survive, and that's already proved, right? So, we at continuum limit, we get the Schrodinger equation. Now, when we extend upon it, we see that different windings are giving us different sort of standing waves. So by weight conservations, we get isospin, we get the color at SU3, and we also get a G2 envelope where we see that all the different standard model particles should converge without any supersymmetry. So this is also pretty huge. And this graph is incorrect, but yeah, vibe researching isn't easy as we would like. And then, when we try to come and understand what's really happening on each voxels, so there is a positive difference weight between all the three axes that each voxel has, and the difference of these amplitudes or integer values is basically where is something falling, we can say, where the slope is of a thing, and the second derivative of this is basically gravity itself, or curvature, sorry, rather than gravity. So that's where the curvature is. And yeah, at continuum limits with our prediction, it gets extended into a Laplacian, I think. And from that continuous Lagrangian Taylor series, we get to the Ledger-Einstein tension and the Einstein tensor. And we are also able to determine that for every walk or feeling in this three spatial in these dimensions, and because of our no double commit rule in the ledger, we see that let's say the recursion. The solution is basically why we are in three dimension. The only integer that satisfies ledger reversibility, parity protection, and norm conservation simultaneously. Now, once we are able to determine the Einstein tensor, we are able to fill it back in our different stable particles and with our phase locking mechanisms. And once we do that fitting, we get without the need of a Mexican hat potential, within 1% error, all the observed particles that are there in our standard model, after the fitting. So, so that we have to show a lot more of the image. So let's see how this one. And yeah, so if you are able to see my image, you'll see that we have these are all the particles that we predict. So there are a lot of that are already there. There's this called as axial lepton, which is at 720 mega electron volt. Then we have a few more, uh, an E naught at 600 GeV, which is basically 5 multiplied by 120. But yeah, it's there. Then we have a weak doublet. Then we have a vector boson, vector triplet at 169 GeV also. This is basically cousin of the Higgs boson, so yeah, Higgs boson, right? So this is basically cousin of Higgs boson. And yeah, we also predict a lot of solid-on states or a wave-like states for the curvature photons are there. Then we have a ledger cue ball soliton. We also have other in the paper, so with W wall, etc. So that's the so if I just come back now, and you guys can have a look over here. Everything's open source in our GitHub itself. And yeah, as I was telling that, I'll just wrap up the paper first today, and then once we are able to we are able to see that the temperature at which these different convergence happen is this over here. Then the temperature at which the universe, the curvature of the universe opens up enough to have some photons is when SU2 to SU1, SU3 to SU2, and then SU2 to SU1 breaks. And it is at 146 giga electron volts. And, we are able to see that at epoch 60 is when the cosmic background wave gets freezed. We are able to derive the baryon symmetry as well from our temperature. And yeah, if I take it forward at this electroweak crossover temperature, uh, we were able to get all the particles, and now all the new particles that we are able to predict. One of the most exciting technologies that are going to be unleashed is the curvature photons, and the dark sector is going to be all visible now. So yeah, so we are able to predict not just one but two. Because L is 16 and then 17, and then there's a some ratio of 0.74, so sometimes we get a 2.8 kilo electron volt X-ray, sometimes a 3.54. And yeah, we are looking to get an axial lepton at 720 mega electron volt. And these tests, so we're looking and we're writing to do new tests, but we are able to go through our past, these are all the new particles, all the past data that's already been there. So if you go through the Chandra data, and if we were able to analyze, so we confirmed in both standard and grade 7 data, uh, with an energy over here, width is that much at a KeV line as well, with over here analysis method. So I don't know how strong of a prediction this is. Significance. These directions provide independent establishing the first two 5 sigma ledger. So this is at a 5 sigma level where we are operating, and we are predicting a lot more particles. So I think humanity can get excited. And yeah, then we see condensed matter and chemistry itself emerging. We see periodic table coming out as we coarse grain the ledger. And I'll skip life for now, but basically, once you are inside the lattice and you are able to predict your error rate, your prediction is better than the error. You are able to uh, self-evaluate your own self, the future as well as the past that's used as the model. So basically, the level of consciousness that we understand. But yeah, we have built upon it. We are still researching. This is a theory of everything. So everything has opened up for us, and we are not fundamentally, researchers. This is purely out of seeking truth and curiosity that we have ended up over here. I'm an entrepreneur. We have been looking to connect the whole world. I see the whole world as one family, and I think, we and our company might be the one who are able to connect it all back. And as we become a spacefaring civilization, hopefully we'll see we are more alike than different. And I think curvature photon is something of that engineering that we are excited to unlock. Um VR headsets that would possibly let a lot of people skip reality itself, so we need people to accept reality and then be over there, so be in this real world. So, and yeah, we are looking at, if I just look at, what are the things that are possible and why should one even be excited about RBT, elaborate, quick 10 points for future of humanity. Exciting. But if I just want to tell that, what we are predicting is that we'll be able to do gravitational engineering, gravitational lensing. We'll be able to get a permanent G acceleration without propellant. And that basically means we'll be heading to our closest solar system, Alpha Centauri, within 4 years, as we'll gradually accelerate to the speed of light and then decelerate as well. So yeah, so we have unified quantum mechanics and general relativity, and so it's a you'll have to study less, and no parameters, so we have removed all the parameters. We have falsifiable predictions. So if this is all wrong, this is not the theory of everything. Please be my guest and let us move the torch and the light of humanity forward with something that's incorrect out of the way. And yeah, so we have practical curvature photon tech incoming. So we have room temperature, solar conductors, we have chip scale cryo refrigeration, we have ring resonators that lock the 12 nanometer mode, self cool and self pump. Gravity becomes engineerable, weight is a digital field. Pattern it and use sculpt curvature locally. Levitation pads, inertial dampers, concrete liquefying gradient weapons. Hence the urgent arms control discussion. We are releasing the whole theory in open source in the hopes that is humanity can handle this, and we'll all come together. Dark sector solved with two particles, so with just a stable 600 GeV cold and a 720 MeV, close the dark matter exactly as it was. Cosmology lockdown, no sprawling axiom, biophysics crossover might be there. We are yet to test it, but yeah, it might be there. Ultimate low power computing, chips clocked by curvature photons hit London limit, exascale laptops without data center. And yeah, so Born rule, arrow of time, and black hole entropy are counting identities, no interplay. Shut up and calculate. Finally, mobs to now we understand and calculate. Biggest takeaway, RBT trades 50 years of ever loser speculation for one simple digital rule that either delivers technology grade predictions within a decade or cleanly bows out. No middle ground. So, what we are looking at uh, is, uh, is a theory of everything where we believe that with 40 lines of code, you can simulate the whole universe, or we can have new chips that can do what five physics engine do today with just one repeatable 40-line kernel code. And we have released it all, so I would love for you guys to check it out over here. We have also detected, like, uh, this is another particle that we've detected. It's a M naught emission line at the 100 EV, and it's with 57 sigma significance as we see. So we are analyzing 90 to 100 EV lines with an annulus link of 30 to 80 around the cluster center, and what we get is a new mass scale in the EUV regime, possible exotic bridge between X-ray and optical steps. And yeah, if we look at the result, we had 14,601. 6,300 might be background, but we are getting 8,261 extra counts, which is 57.1 sigma for the M naught emission line. that we are predicting in a 30-year-old archival data. So that's there, and yeah, we have everything in open source on the RBT0 page. We have also done a lot of math, but I'll skip on it for now. And yeah, feel free to drop by in your comments, and we'll keep working. Have a good day and a week, everyone. Zo, zo, zo.